Hello class, this is just a short video clip I wanted to put out there for your question page 379, question 10. I did not assign that for homework, but it's something that we need to be able to talk about and figure out because it's going to be something that you'll have to do. I want to just read the directions here. It says to write the nuclear decay equation for the following reaction. Refer to the periodic table for atomic numbers and names of the resulting isotopes. So what I did was to write out what they gave us and basically what they're telling us to figure out. First off, I want to you've already mentioned the fact in one of your homework questions that there's three kinds of decay: alpha, beta, and gamma. And in the alpha decay process, basically a helium atom is given off. Has 4 at the top and 2 at the bottom. It's going to change by those two. A beta decay is going to be essentially an electron being given off. The top number will change by 0, the bottom by a -1. And gamma, which is shown by this little kind of curly Y kind of a symbol, is not going to change by any number, the top or bottom, but it does get given off in the form of energy. And we know that gamma rays, we've talked about this already, gamma rays are very powerful rays. So I want to look at this first question. It says gamma decay of I-128. So always you're going to write the mass number on top and the atomic number on the bottom. So it tells you in parentheses that Z, or the atomic number, is 53. So this is how you're going to write your I with a 128 at the top and 53 at the bottom. And in our equation here, what we're going to do is to recognize that we're starting off with this I-128 with the atomic number of 53, and it's going to go through the process of gamma decay, and what we're going to be left with on the other side is this plus a gamma decay material. So if you notice, both of these numbers are going to stay the same because our 0 and 0 are not going to be affected. So that's going to be the way gamma rays affect an element, but what we're going to see here ultimately is that the number on the first side of the arrows, those two numbers are going to have to equal whatever combination of numbers you have on the second side of the arrow. So for this particular problem, it's not going to change, okay? But what I want to show you is this next one is not going to be the same way. You're going to set up PU, which is 246 at the top, and it tells us our atomic number already, 94. And what we're going to do is to write whatever the element's going to become, and because it's beta decay, we know that it's not going to have the same number on top and bottom that it did to start with, okay? What we're going to recognize is whatever element we're left with is going to also be a combination with this beta molecule that's given off, right? This electron. So what we're going to do is to think about what number that we're putting here along with this -1 to be the same on both sides, right? Remember, energy and matter cannot be created or destroyed. They can change form, but they cannot be created or destroyed. So whatever we started with at the beginning has to be accounted for at the end, right? So if we think about it, what number are we going to subtract 1 from and still get 94, right? And that number hopefully will be a number you recognize as 95, right? 95 minus 1 is 94, so that's going to be our total that we started with being accounted for at the end. 246, on the other hand, And 0, that number is going to stay 246, right? Because 246 plus 0 is still 246. So what we started with at the beginning, we have to account for at the end. Now, one thing I want to show you is that this atomic number change essentially is going to change the identity from what we started with. We started with plutonium, Pu, but what we're ending up with is not going to be plutonium. It's going to be something that has an atomic number of 95. So I want you to look on your periodic table of elements here for something that has 95, and what you're hopefully going to see here is that it's americinium, and the abbreviation is AM. So that's going to be the material that we end up with. So we're going to write AM 95 246, right? So our elements, our process of decay is going to look like this. Let's go ahead and do one more of these. And we're going to, it tells us in our problem that we're starting with radon. The symbol you can get from the periodic table of elements, but radon is Rn, and it's 210 at the top, and it tells us in parentheses that Z, or the atomic number, is 86. Alpha decay is going to give us a change in both the top and bottom number by this material being given off, right? So we need to, again, recognize that what we start with and what we end with has to be the same on both sides. So we're going to think, what do we do to 2 to make it become 86, right? Hopefully you can think about it backwards, like 86 minus 2 is 84, right? 84 plus 2 is 86. And 210 minus 4, right? 210 minus 4 is going to give us 206, right? 206 plus 4 gives us 210. So that's what we started with, that's what we're ending up with. And now we're going to go back to our periodic table, and there's one in your book on page 392 and 393, and we're looking for something that has the atomic number of 84, right? So we look here, here's 84, and it's polonium, PO. So instead of being left with radon, we're left with polonium. And notice it's capital P, little o, capital A, little m, right? Capital R, little n. So polonium and your helium molecule. Let's do this last one. So it tells us we're going to experience beta decay, right? Again, your electron being given off. And we start with 138, and cesium has the atomic number of 55. So we're going to think about what are we going to do to this number that's going to have these parameters here that we have. What could we combine? 55 minus 1, that is backwards from what we did before, right? What we could say is 55 minus a minus 1, right? 86 minus 2 is 84. So 55 minus a minus 1 is really 56, right? 56 minus 1, 55. And our top number, 0, doesn't change anything. We're still left with 138. But this 56, we're going to look back at our periodic table here and look for the element 56. Let's see, where is it here? Here we go. Barium. Barium is 56, okay? And the symbol is Ba. So what we're going to write here is Ba. The information that helps us know it's Ba comes always from the atomic number. Think of the atomic number as being the identification, kind of like your social security number, something unique to you. So this atomic number unique to only barium. The atomic mass, the mass number can change, doesn't matter, doesn't influence the element whatsoever. It's really only the atomic number that influences this. So you're going to see this again. I'm going to be giving you some problems after our break next week. So it will be Tuesday the 14th. I'll give you a problem that is similar to this that you're going to have to use this for. But I just wanted to give you a heads up for that. Have a good day.